So we have finished chapter 1 about photoelectric effect. We talk about the Rutherford model of atoms. And we see there's something wrong with the Rutherford model. So we got to have another solution, another model for atoms. Then the second part of the first chapter talks about photoelectric effect, which tells us that light can be particle sometimes. And we have that very simple experiment to show photoelectric effect. We know how to find the energy of a photon. We also know that there is a certain energy to be done in order to remove an electron from the surface. The minimum energy to be done is called work function, and then different metals may have different work function. So finally there is the Einstein photoelectric effect equation. And using this equation, would you turn to this page, page 19. Using this equation, then we may plot a few different graphs. So that one on page 19 at the corner, would you please draw this graph? The graph has maximum kinetic energy as vertical axis, and then horizontal axis we use F, frequency. So it is just like saying this is Y, which is the vertical axis, and then F is X, so the horizontal axis. In that way the slope is H, and then you may also see the intercept to be F log, which is flexor frequency, and also the vertical intercept is negative of work function. Would you copy that down? Alright, this is so important. We may also plot another graph such as this on the next page. Would you also copy that down? On the next page, top left hand corner, would you copy that down? What is it? This is velocity square versus F. So the slope will be 2h over me. Me is the mass of electron. Okay? Would you copy that down as well? So that ends chapter 1 about photoelectric effect and atomic structure. Now we move on to chapter 2. So the title is Towards the Modern Atomic Model. So it's about atomic model. It's about the Bohr atomic model. Okay, so this chapter is talking about the Bohr's model of hydrogen atom. Alright, just hydrogen atom is already difficult enough, alright, to make you crazy. And then in this chapter, alright, in most of the time we are talking about the light spectra. What is light spectra? Well, you go to Google and then you type spectrum, and then you click graphics, then you will see something like this. And obviously this is electromagnetic spectrum. And then if you go through, alright, the pictures, then you will find also this one, which tells you that white light can be decomposed into different colors like this. A colored spectrum like this. Well, that color spectrum from a light source, for example sunlight, alright, then it may form a continuous spectrum. However, if the light source is hot dilute gas, for example, we got a tube or a hydrogen tube, just like a fluorescent lamp, and then we excite the hydrogen inside. Then the hydrogen may produce light as well, but this light will then finally form something called emission spectrum. It's not continuous spectrum, but it is a light spectrum. Lastly, if the light from a normal light source passes through cold gas, the cold gas molecule will absorb some of the light, and then the light finally passes through the prism, and then it will produce an absorption spectrum. This chapter is going to talk about these three different kinds of spectra: continuous spectrum, emission spectrum, and lastly, absorption spectrum. So now we turn to this page. Alright, chapter 2.1, atomic spectra. So many different kinds of spectra. Alright, the first one is from the sun. Basically, the sun is a bit special because the sun is a very hot ball of hydrogen, alright, and because of the very high temperature, so light produced by the sun may have any frequency, so it produces a continuous spectrum. However, scientists find that in some very special case, we may not have a continuous spectrum. We will explain this very soon. Let me repeat that one more time, alright? We study light spectrum because light spectrum will tell us something more about atomic structure. The Rutherford model is not perfect. The Rutherford model has something wrong, alright? Something that cannot be explained. So we have to study light spectrum to know something more about atomic model. Now look at this picture and see what he is doing. He is now looking at a hydrogen discharge tube. A discharge tube is just like a fluorescent tube, alright? But then inside there is hydrogen gas. But there is no mercury, no fluorescent powder, no, alright? There's just a glass tube with 2 electrodes and then with hydrogen gas inside. So using electricity, the hydrogen gas is excited and then hydrogen gas produces light. And then you can see the gentleman in the picture used a plane transmission grating to look at the light produced by the hydrogen discharge tube. A plane transmission grating forms multiple slit interference, and so we may know whether the light from the hydrogen discharge tube is a continuous spectrum or a line spectrum. So now let's go through the video and see what happened inside.